Hey everybody, and welcome back to Algebra 2 online. So the plan for today is just do a few problems that will help you kind of get ready for the Unit 5 quiz. And so for this first one, this is kind of one of those like general concept questions with how these polynomials look. And so you definitely want to know how to do this for the quiz. It's an important kind of part of this unit. But this one says that you have a polynomial that's got negative leading coefficient, it's odd degree, and has 3 real and 2 unreal roots, right? I guess I don't really need that because it has 3 real and 2 unreal, so you can get rid of that. But anyways, basically here, the big thing to know is just that, if you take positive x cubed, it kind of looks like that. That's like our positive odd ones. They're going to go, start down here, and as you go over, they're going to end up here. And so if you have like negative, like odd degree, like something like an x to the 5th or whatever, which is what we have, it's going to start up here and it's going to end down there. Okay. So you have 3 real roots. So maybe we'll just do 1, 2, 3 real roots. And so we start up here because it's negative, let's say. We're going to come down, do that. And if I just ended it, right, that doesn't necessarily show the 2 unreal roots. And so we need to do, something kind of like that, just to make sure we show the unreal roots. So, this part is like the 2 unreal roots, and then 1, 2, 3 real roots. And the fact that it trends down over time is the link to the negative leading coefficient. All right. So for this one, it just says, write in standard form the smallest degree polynomial that has zeros 2 and minus 3i. All right. And if you think about it, this one's trying to be a little tricky, but it's not that tricky, because you can't just have a root of minus 3i, unless actually you have imaginary coefficients, but assuming that you don't have imaginary coefficients, then you would have to have a positive 3i root right here. And this is just coming out of the quadratic formula. Like if you have x equals 2 plus or minus square root of negative, whoops, I said it, but I didn't write it, negative 9, over 7 or something. This part in here is where you're going to get imaginary numbers when we solve these problems. Again, unless the coefficients are imaginary, but we haven't really seen that, and that's not something I plan to do to you. So you're basically always going to get pairs of these roots. So if I write minus 3i, then you should have a plus 3i one that kind of goes with it. And so, basically, if you know roots, you can convert that into factors. That's how I would think about this problem. So I've got x minus 2, corresponding with the root of 2. And then I've got x, we'll say plus 3i, corresponding with the root of minus 3i. And then we have x minus 3i, which would correspond with the root of 3i. And then basically we just go and multiply the whole thing out. Because this is in factored form, and I asked for standard form. So I got that. And then this part in here, if you multiply all that out, you're going to get x squared plus 9. Right? And then if you, like this part right here. And then if you multiply, whoops, I didn't even do it. If you multiply those last two, you're going to get x cubed plus 9x minus 2x squared minus 18. And that's it. That is a standard form, smallest degree polynomial that could have these roots and also have real coefficients, which is what we're sort of used to. When you start adding in I times x cubed and stuff, that's how you can get because then you could have if you have an I here in your quadratic formula, you could have an I here. And so, we don't really see that in this class, but technically that's a thing in math. But this is the one that I would kind of expect a lot of you to do. All right. Another big thing is just finding roots. And so this question just asks for find all roots of these two polynomials. And so the first one is a fourth degree here, the first factor, and this one's also a fourth degree. So basically you should have, max degree is 8 if we multiply this one out. So we're going to need 8 roots of this polynomial. What I would do maybe first, you could take x cubed out of that. You get x minus 2. And then we're just copy this down. I was thinking about saying something about that, but I'm going to wait. And then, honestly here, you have 3 zeros pop up as roots, and then here you have a root of 2. So honestly, we are halfway there, right? The only one that we got to do now is this other one here. And for that one, I would just do u sub, because it's got that nice structure of x to the fourth and then x squared. So it's got the doubling and the 3 terms going on. So that's why it's like a perfect u sub. So I'm going to always let u be that middle term variable. So let u equal x squared. And then u squared, right, would be x to the fourth. So really, we're trying to solve u squared plus 6u plus 8, which is actually also a nice quadratic in u. You get u plus 4 and u plus 2, and then u is negative 4 or negative 2. And so then we just kind of do the unsubstitute kind of idea, like u is x squared, so we're going to have x squared is negative 4, or x squared is negative 2. And this one, we would have plus or minus 2i. And this one, we would have plus or minus root 2i. And that's it. You got 2 roots there. Do a different color here. 2 roots there, 2 roots there, 4 roots there. 2 plus 2 plus 4 is 8. Those are all the roots I would need. This bottom one is just another one of those factor by grouping problems. So if you ever see 4 terms, you can bet that I'm trying to get you to do factor by grouping. And when you do those problems, you just want to take out factor out of each group the max amount that you can. So in this first group, we can take an x to the fourth out, and we'll have x squared minus 2. And then in this second group, the most we could kind of take out is minus 4. And then you'll notice you'll have x squared minus 2. Yeah. And so the idea with these is really you're looking for some sort of common factor like you got on these two. And then you can take that out of it's kind of like that idea of double factoring. I factored each group, and that's kind of one of my steps for factoring. And my second factoring step is to take the common GCD out of both of these. And in the first one here, I would have x to the fourth left over, and then here I would have negative 4 left over. And now you've got it reduced to a point that's actually fairly nice, because this one you can just go and answer. That's plus or minus square root of 2 are the roots, right? This one is difference of perfect squares. So you can think of it as x squared minus 2, x squared plus 2. And then here, it's literally the same as that first quadratic factor. You have x squared minus 2. We had it before. Same roots, plus or minus root 2. And then here, because you want to think of this quadratic as shifted up off of the the x-axis, then it has imaginary roots, and basically they're the same kind of number, just stick an I on it. And that's it for that one. So you got 2, 4, 6, and that's the maximum roots that we should be finding here. All right, so one more, just find all the roots problem. And this is about as big as they're going to get. I don't plan to do many that are bigger than this, and I just thought it'd be good to show you one that kind of is large. So x to the ninth is quite a few roots, and at this point, they still have to satisfy some nice structure to it. There is one more technique that we're going to learn that basically helps us do this when the two techniques that we have don't work. But right now, you either are going to do factor by grouping or you're going to do substitution. So for this one, we'll have to do one of those or both of those. And so if I was starting off, remember, substitution only works if you have 3 terms. We definitely don't have that. So we would make sense. The only thing we could do to start off is factor by grouping. And so you got to look at, you kind of want to look at the ratios of these numbers. And you either have an option where it's 2 groups of 3, or it could be 3 groups of 2. And if you look at the numbers 50, 20, 5, 2, 45, 18, that's always a ratio of 5 to 2. And so you can kind of see it that way that, you should probably do 3 groups of 2 is the idea. So I'm just going to take out as much as I can from that group, and then that group, and then that group. And then you'll see a common GCD in there. So when I take out from the first group, I'm going to get 9x to the 8th is like the most I could take out. And I would have 5x plus 2 left over. That's that group. This next group, if I take out minus 10x to the 4th, I will also have 5x plus 2. And then this last group, you have a 5x plus 2. So you can really, if you want to see it better, 5x. Oh, wait, yeah, no, it is minus. I was saying plus the whole time, but I was not looking at what I was. I took a minus out of this one, so that will be minus there. And then likewise, here I took a positive out, but it was a negative 18, so it should be a negative 2. So then, so that's the factor by grouping step. So all this stuff equals 0. And then factor by grouping, the idea now is we're going to take this common factor out of the whole problem. So we take that out, and we would have 9x to the 8th minus 10x to the 4th plus 1 left over, right? And you probably see where this is going. You have, this one is fine. We've got it down to a linear factor, and we could solve that really nicely. This, though, we need to get it down to either quadratic or a linear factor in order to solve it out fully. And you can see right now I've got 3 terms, and I've got that nice doubling with the exponents happening. So this is a prime, U sub problem now. So basically let u equal x to the 4th. So then u squared is x to the 8th. So I've basically got 9u squared minus 10u plus 1. And that thing, you could try and factor it. It's actually not that bad. But you could also just do quadratic formula. Really doesn't matter. I'll just do quadratic formula. I mean, typically when this is a big number, like 9, I just jump in and just do quadratic formula because you're going to have options that are it's like a lot of cases to think about, right? So I'm just going to do quadratic formula, but you can absolutely factor it too. You'll have 10 plus or minus 100 minus 4ac all over 2a, which is 18. And I'm just going to do this out on a calculator, and I get 1 1/9, okay? And so then, basically at this point, we've got to think about it in terms of what u is, right? So u is 1, but u is also just x to the 4th. Likewise, u is equal to a 9th, but that then means a 9th equals x to the 4th. And then, you could do square roots and just be careful with your pluses and minuses, but I'm going to convert them both into differences of perfect squares because that's something that's nice in both of these. So I'm just going to subtract the number over on both of them. This one would factor into x squared minus 1, x squared plus 1. So the roots here are plus or minus 1, and here it's plus or minus I. And then here, you would factor this into x minus a third and x plus a third, right? X squared. Still differences of perfect squares. And then, here now we get nice plus or minus square root of a third as the roots. And here, likewise, plus or minus square root of a third, I. And if you look at it, right now we got 1, 2, 3, 4, 5, 6, 7, 8. And you might think that we're forgetting one, but don't forget about this one, right? So if you pull that kind of over here, you can see if you just add 2 and divide by 5, right, you're going to get 2/5 as the ninth root. This is about as big as they get in Algebra 2. So, technically there's times where you run into even more, but if you can do this, you could probably do any of them. But yeah, so that's like a good example of one that uses both techniques we've learned. So another one, another concept that I do want you to know is if you get some sort of polynomial like this is some x cubed thing with some weird decimals and stuff. If you get this kind of thing, you should know how to use your calculator, your graphing calculators, to do that max, min, and zero thing that was in the last video. And that's just going to be a really helpful thing for you to model different graphs, basically. Sometimes, you can really get a good sense of what's going on because of, actually this is actually a fairly nice polynomial because of all this structure here. But this one, you're not going to be able to do that. You can't do, substitution, and you can't do factor by grouping. It's really messy with anytime you just start getting some weird decimals. And these ones are the ones that are very common in the real world, right? So you want to make sure you know this. Now, I'm not going to open up a graphing program on here because I can't do that. But if you want, just wanted to make sure that you kind of saw one that I'm thinking about with these. So if it's one like this that you can do fully out, I expect you to do it fully out like that. But something like this, we would just analyze it with the max, min, and zero buttons on your calculator. So make sure that you do know how to do that too. All right, and last but not least, the very first thing, honestly, that we did is just simplifying some stuff with polynomials and exponents and all that sort of stuff. And so you should be able to do all this too. If I was just subtracting polynomials like this, then basically you're just looking for like terms, right? So if I do 3b to the fourth minus b to the fourth, I'm going to get 2b to the fourths. And then if I do minus 6 minus a negative 3, then it's going to really be a plus 3. And so you're going to get minus 6 plus 3 is minus 3. And then it's a little hard to see, but actually here we'll do. Here we go. So this last term that I haven't talked about yet is the cubed term. I just covered it up again. I erased it before so you could see it. And that one, you just do 8b cubed minus a negative 7b cubed. And so then you'd add 7, right? And 8 plus 7 is 15. So you're just going to get 15b cubed. So adding, subtracting, fairly straightforward. Multiplying is also pretty straightforward. If you have this, right, you just double distribute here. And we've been doing this forever, right? Boom, boom. And we would just get this right there. And then, the last kind of thing here at the bottom, I do want to make sure that you just kind of don't forget how to work with exponents and things. So, if we just have one term inside, like this is all just one term, right? There's no separation with pluses and minuses, then, if we were squaring this, we can basically, in a sense, kind of distribute that square to everything here. So we can get x to the negative 2, y to the negative 2, x to the negative 6, x to the 8th, right? And then, you can proceed, different ways. I might simplify the bottom just to, if I have x to the 8th times x to the negative 6, I'm going to add those exponents and I'll get x squared. And then negative exponents are on, basically as an indicator that it flips the side we're on. So negative 2 on top is 2 on the bottom, and I had 2 already on the bottom. And then y to the negative 2 is also 2 on the bottom. And so the only other thing I could do here is combine those x's, and I've got 4 of them on the bottom. So you could write it like this. And you could absolutely write it with negative exponents too, but it's just good to make sure that you know how those do change the answer. And so that's just like a quick overview of some of the stuff we've done recently.